In this video, we're going to learn how to graph trigonometric functions with a phase shift. Now, just to go over, we're going to go over what amplitude and period are. Now include phase shift and vertical shift and how to read those from a function. But with this function here, in order to read a trigonometric phase shift, the first step you'll need to do is actually factor out the omega from inside trig function without taking it out of the trig function. So if I were to factor out omega, I'll end up with x minus phi divided by omega plus b. So once that's factored out, you can see a list of everything that you can read just from the function alone. Amplitude being whatever the absolute value of a is, the period being 2 pi divided by omega, the phase shift being phi divided by omega, and the vertical shift just being that b value at the end. So we're looking at this first example. We're going to find this amplitude, period, and phase shift, and then graph the function. So I see that I have this negative 2x, so I'm going to factor that out first. So I'll have y is equal to 3 sine of negative 2 times x minus pi over 2. Now I still have that negative of the inside of a trig function, so I can also use the even-odd properties to take care of that. And I'll have negative 3 sine of 2 times x minus pi over 2. Now reading all of this, my amplitude is going to be 3. My period is going to be 2 pi divided by 2, which is just pi. And my phase shift is going to be pi over 2 to the right. The reason why I know it's to the right is that I'm doing a minus pi over 2. So that's a positive pi over 2 according to my original formula up here. If I was adding, that would be a negative pi over 2, which means I would go to the left instead. So knowing all of this, let's get into how to actually use these key points, how to alter them when I know I have this change in period and phase shift. So first, I'm going to look at y is equal to sine of 2 times x minus pi over 2. So what the phase shift tells me is now, instead of starting at 0, since I'm shifting to the right, pi over 2, I will now start at pi over 2. Now my period is pi, so where I end up, it will be pi away from where I begin. So pi over 2 plus pi is where I'm going to end, which will be 3 pi over 2. Now, to figure out how much you count by as you go up, it's still done in the same way. As you would have done before, you would take your period and divide it by 4, pi over 4. So I'll do pi over 2 plus pi over 4, which will give me 3 pi over 4. 3 pi over 4 plus pi over 4 gives me 1 pi. 4 pi over 4 plus pi over 4 is 5 pi over 4. And then add another pi over 4 gives me 6 pi over 4, which is 3 pi over 2. And now we're done taking care of the phase shift and the period. Usually you'll do them both at the same time, since one just tells you where to start, and the other one tells you how far to go, so you can figure out where to end. So next, we're going to figure out what this negative 3 does to our y values. So now we have y is equal to negative 3 sine of 2x minus pi over 2. All that stuff has taken place already. I'll write down that I've already taken care of all of my x values. So I'll write those down unchanged. And now let's look at what happens to the y values. So 0 times negative 3 is 0. 1 times negative 3 is negative 3. 0 times negative 3 is 0. Negative 1 times negative 3 is 3. And 0 times negative 3 is 0. Now we'll go ahead and plot these particular points. So we'll have pi over 2, 0, 3 pi over 4, which is right here, -3, pi 0, 5 pi over 4, 3, and 3 pi over 2, 0. And this is one cycle. Now I'm going to keep this one in red and draw the rest of the graph in blue just so you can see where everything has shifted. Because now if I follow this pattern, again, this is at 0, now I'll go down to -3, then back to 0, then +3, then 0, then -3, then 0. It will just continue to wiggle. And I can also do the same thing backwards. So if it's at 0, if it was at -3 here, now it's going to go up to +3, then back to 0, -3, 0, +3, 0, -3, 0, +3, 0, -3, 0, and you'll see that this pattern just keeps on going, and this will wiggle for a very long time. You'll see here that this graph does look like a normal sine and cosine graph, but it would be hard to tell where it shifted to. But now you can see that it did shift to the right because now its starting point is where it is in red right now. But it still goes through the origin like normal. But now it starts here and continues onward. So that's the effect of the phase shift. Is normally I would have been at 0 to start with. Now I'm over here at pi over 2 to start with. But I can still follow the pattern in both directions as well. Now let's look at this next example. 2 times cosine of 4x plus 3 pi. And again, it's, plus 1. And again, the first step is we're going to factor out that 4 on the inside. So we'll have 2 cosine of 4 times x plus 3 pi over 4. And then plus 1. So now I can see my amplitude is going to be 2. My period, 2 pi divided by omega, which is 4, so pi over 2. And my phase shift is going to be 3 pi over 4, but this time I'm going to the left since I'm adding. Because again, that'll be like minus -3 pi over 4. So I'll be shifting to the left. So when I go to do this next step, where I'm going to see what happens with my period change and my phase shift, I'll see that now I'm going to start at -3 pi over 4. And my period is pi over 2, so I'm only going to add pi over 2 to -3 pi over 4, which will bring me to -pi over 4. Now, what do we count by? Well, we're going to have to divide our period by 4 to figure that out. So pi over 2 divided by 4 gives me pi over 8, so I'll count by pi over 8 every time, which brings me from -6 pi over 8 to -5 pi over 8. To -4 pi over 8, which is pi over 2, to -3 pi over 8, and then to -2 pi over 8, which is pi over 4. So on my graph down here, I left it blank for the instant because I couldn't tell right away where I was going to have to put all my tick marks, but I'm going to put them every pi over 8. So if I skip 2, that'll be pi over 4, then pi over 2, 3 pi over 4, pi, 5 pi over 4, and going backwards, -pi over 4, -pi over 2, -3 pi over 4, -pi, and -5 pi over 4. That includes my -3 pi over 4, to my -pi over 4, and some extra space as well, and it's counting by pi over 8, so make it really easy to graph. Now let's see what's going to happen with my change in y values. I'll start with multiplying by 2. And we have cosine of, I'm going to rewrite it as just as 4x plus 3 pi just to save some space. but we've already taken care of all those. In fact, I'll go and copy paste them down since I'm not going to have to deal with those anymore for my key points. Just going to have to focus on my y values. All right, so now we're going to start by multiplying them by 2. So 1 times 2 is 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. 0 times 2 is 0. 1 times 2 is 2. And now we'll add that 1. So we'll get y is equal to 2 cosine of 4x plus 3. But now we'll focus on the plus 1. So 2 plus 1 is 3. 0 plus 1 is 1. Negative 2 plus 1 is negative 1. 0 plus 1 is 1. And 2 plus 1 is 3. So now we've gotten all of our points. And if you even want to think back to here, there is a vertical shift taking place as well. Of 1. And that'll be 1 up. You'll see that as I go to graph. So starting here at negative 3 pi over 4, it's going to be at 3. Then negative 5 pi over 8, which is right here, it'll be at 1. Negative pi over 2 will be at negative 1. And then 1 at negative 3 pi over 8. And then 3 at negative pi over 4. So again, this is one cycle of cosine. But I can also continue that same pattern every tick mark. So now it goes down to 1, then negative 1, 1, 3, 1, negative 1, 1, 3. These are periodic functions, so they do repeat their patterns forever in both directions. But as you can see, this graph has been shifted more upwards than the graph you see over here. That's that vertical shift of 1. That's what that plus 1 does. And you've seen those before as we graph with transformations, but I just want to put a name to it. So you can look at it and be like, oh yeah, there was a vertical shift upwards by this many units. Sometimes if you can identify what the center of the function is, which looks like it's right here, you'll see that it's shifted up 1 from the x-axis. Again, highlight in red where the function started, where one cycle was with the phase shift. But again, it's hard to tell because usually cosine would start at some value on the y-axis. And that is how you graph trigonometric functions with a phase shift.